There we go. Okay, great. Thank you all for tuning in to today's installment of the Corundum Developer Meeting. Today is going to be a little bit different because I'm going to be talking about kind of the long-term sustainability of Corundum, but more details on that in a minute here. First, we got a couple of announcements. The next developer meeting potentially is going to be October 2nd, although depending on, proximity to ISPCS, which I think I'm going to be attending, that one may need to be rescheduled or canceled, depending. Potentially more details on that later. The next Switch developer meeting is probably going to be on September 11th, which will be in a week. I guess I'll confirm with Carlos and let you guys know in the corresponding channels. I think that about rounds it out for the announcements. So moving on to sustainability. So early last month was SIGCOMM, and at SIGCOMM we presented a paper, Realizing RotorNet, which basically tied off the research project that I've been working on at UCSD for the past several years. So the research project itself is in terms of optical switching and data centers, but Corundum was basically developed for that particular research project. And I've been very privileged to be able to work on Corundum full time as a PhD student and as a postdoc for the past several years. But now that we've submitted that, the research project is done more or less. The grant is complete at this point. So the question becomes, what is next for Corundum? How do we prevent it from becoming, yet another abandoned open source project? There's certainly a lot of those on GitHub. It would be very unfortunate for Corundum to become one of those. So what do we do? And really the problem here is that Corundum, it's a very complex project. There's a lot of code. There's a lot of tightly interconnected pieces, and really proper maintenance and development realistically is going to be, several full-time jobs to, continue adding support for new boards, continue improving the performance of the core code, continue adding new features, things of that nature. It seems that most of the people using Corundum are mainly interested in just adding their own code on top of it and not so much maintaining Corundum as a platform. Not that there's anything wrong with that. It's wait, some big black window just popped up randomly on my computer. That's strange. I'm not sure what's up with that. Anyway, most people just want to use Corundum and add their own code on top of the core, platform instead of actually digging down into the platform and, building it and maintaining it internally. And there's nothing wrong with that. But unfortunately, tragedy of the commons, if nobody in the community can devote time to, helping maintain the code base, then that's a problem. And I think this is kind of an unfortunate side effect of using a permissive license is, there's really not any leverage to get, people that are using it to pay for it in some way, because you can just take the code and run off with it and use it internally without, having to provide anything back to support the project. So while I was in Sydney for SIGCOMM, I did a lot of thinking about this, trying to figure out, okay, well, what is the story with Corundum, and what can we do to improve the situation and actually make it something that's going to be sustainable and be able to stand on its own for the next few years. And I went through several different potential solutions, and I think most of these don't really make a lot of sense. So it's like donations. There are some open source projects that are supported through donations, but Corundum is too niche. There's not enough people using it. It's like, let's say every single person currently using Corundum donated $1,000. I don't even think that would be enough to pay for a single developer full time. You know, and that's the very unrealistic scenario in the first place. Some sort of a scholarship or a grant. I mean, it's it'd be possible, but it relies on the long-term generosity and support of external parties. And if that dries up, well, then you're back in the same spot. So that's not really helpful for on its own, at least. That's not really helpful for long-term sustainability of the project. And another option that I was mulling over as well is like consulting slash paid support. And on one hand, that seems reasonable. A company can pay for getting help with, their particular project. But, um, one, my time doesn't scale, right? And two, time spent working on other people's stuff is time that can't be spent working on Corundum. So, if I'm working on somebody's application block, okay, that's great, but that time's not being spent towards working on the platform itself. So while I'm potentially going to be doing some consulting, um, that I think is, tangential to, Corundum maintenance. That's kind of a separate thing. So what I'm thinking is going to be the way forward is to well, the other thing I'd like to do is to keep Corundum open source, right? So that the research community can continue to take advantage of that code base for, new and interesting and groundbreaking research. Definitely talked to a few people at SIGCOM that have been using Corundum or thinking about using Corundum for various projects. I've seen a number of research papers building on top of it, which is really cool. I'd like to, continue enabling that if possible. So what I'm thinking is going to make the most sense is to move to a more restrictive open source license. And if we do that, then that potentially means that there's a possibility to dual license with a paid commercial license. So CERN has their open hardware licenses. The open hardware V2 strict license basically acts like GPL. So if you use that license in the code base, then whenever you distribute the final product, the hardware, the compiled software, whatever, you have to release the complete source code, at least to whoever's using it. Um, and this is not great for a lot of companies that want to keep all their secret sauce protected. So that potentially provides some incentive for actually licensing the core code base. So the idea here is that academic research can continue to use the code free of charge, and potentially can also be used for internal, R&D if it's not being, um, you know, deployed somewhere or distributed. Then that doesn't trigger the need to release the source code. But for commercial users that want to they want to build the product based on top of Corundum, well, then they can pay a licensing fee that will go to support the continued development improvements of the core code base. But in order to do a license, you have to actually own the copyright. So potentially what needs to be done there is a rewrite and then a CLA for contributions going forward, which would be a lot of work, but I've been considering doing a rewrite into System Verilog anyway. Right now that the research project is done, we definitely don't have any reason to have to run stuff on, 6 series devices anymore, which is one of the main reasons I was working with Verilog in the first place anyway. Um, so that might actually be a potential option. So to facilitate this, I've set up a an LLC that I can use for consulting and potentially to hold, the IP for Corundum and potentially other things. There's not much on the website yet, but the link is there. Um, and so I've got that set up, and we can potentially use that going forward for Corundum and potentially for other things as well. We'll see. And then in terms of the System Verilog rewrite of Corundum, right? So if I'm going to take Corundum and I'm going to rewrite it in System Verilog, the whole point is to be able to use, System Verilog interfaces and whatnot across all the components. So it doesn't make sense just to rewrite Corundum itself. The only thing that makes sense is basically to rewrite everything, including all of the libraries that Corundum uses, such that, the nice System Verilog interfaces can be used throughout the entire code base to simplify and, get things a little bit better organized. And it's also an opportunity to, do some additional cleanup optimizations and, get rid of some old code that doesn't really serve much purpose. I know there's like a bunch of stuff in, the Ethernet repository, for example, that was basically just put together as sort of a proof of concept type stuff that's not really needed at this point. So an opportunity to get rid of some of that. Also in the PCIe repository, there's literally 3 different DMA engines. And we don't need to keep all those around. We can just keep the most recent one. Although maybe we'll be putting together a completely different one. We'll see. But it's also an opportunity to make much deeper architectural changes that potentially improve the performance, capabilities, flexibility, etc., without having to deal with compatibility constraints. For rewriting the whole thing, we can make serious changes to the driver as well to make everything work. Um, so just as a brief overview of what some of those changes might be, um, I have this Agilex I-series dev kit lying on my desk right now. So I've been thinking about potentially, higher link rates and more PCIe bandwidth, right? Could we get up to Gen 4 by 16 or Gen 5 by 16? We need to run the core clock at a higher frequency. We need to run with much wider interfaces. We may need to look at, more segmented interfaces, maybe even moving away from AXI stream for the internal interfaces if you want to hit some of these higher line rates. So those are potentially options that are on the table. If we're doing a rewrite, then we can reconsider what those internal interfaces would look like. Obviously, they can always be adapted to AXI stream with the corresponding performance penalty if necessary. But by supporting different interfaces internally, it can potentially enable you to hit much higher link rates. There's also lots of stuff I've been thinking about doing with the descriptors in terms of supporting variable length descriptors and inline data and things like that. We can roll that into the rewrite as well. Another thing that I've been bouncing around a bunch is interface improvements between the driver and the hardware. Basically getting rid of most of the controlled register space and moving to using command queues where you write, to allocate a queue, you would write a command into a command queue, and then the hardware would process that and perform, the correct operations internally. The idea behind doing something like this is it means you can have kind of a lowest common denominator sort of thing between the hardware and the driver, such that, as the hardware evolves, you'll be able to use old hardware with new drivers and new hardware with old drivers and still get some baseline of functionality. Instead of the current setup where you just get some cryptic error message about a register block not being found and then it doesn't work at all. So this could potentially open up the possibility of, upstreaming some of the components as well, right? If we get the driver into the Linux kernel or the driver into DPDK, if we have, less coupling, that's going to make that easier to maintain going forward. Also, we can look at getting, higher precision time synchronization components, White Rabbit, PTM, etc., integrated in. It also would be good to get SRIOV set up. I know there's a few components that are necessary for that, including, keeping track of the VFs associated with everything. One thing that somebody asked me about not too long ago is the potential of basically implementing VFIO in hardware. I don't know if that necessarily makes sense for, the main Corundum interfaces, but, maybe it makes sense on the VFs, right? If you have a VF that speaks VFIO, then you can just pass that through to a VM and you don't need to load any new drivers if the VM already knows how to speak VFIO. So that's one potential benefit as well to using, command queues and soft cores type stuff is you might be able to do some translation even to very different interfaces such as VFIO. I need to do some reading on that. I don't know how realistic that is at the moment, but something to think about. And also the potential for supporting RDMA. Obviously, I was wanting to support RDMA with the current version of Corundum, but there's a lot of, building blocks that are necessary for it to work, like the variable length descriptors and whatnot. But if we get that stuff incorporated into the architecture of the new version, that would make it possible to support, things like RDMA with good performance. XDP, I know there's people that have been interested in that. There have been some implementations of XDP on top of Corundum. But it would be useful to get that, integrated in properly into the new architecture to make that work from the get-go. And then also, improved scheduling. I know, this is something that there were a couple papers about at SIGCOMM that looked at, how to do, precise flow control or not precise rate limiting and whatnot in a more efficient way in hardware. So potentially some of those ideas could be incorporated into the new design as well. And also getting things like, PFC and prioritization working correctly. I think with the current setup, there are some, headline blocking issues and whatnot. But if this can be sorted out architecturally with the new setup, then that could be a really powerful capability. So I think that about brings me to the end of the stuff that I wanted to talk about here. The gist of it is that, in order to make the project sustainable, it makes sense to do this, do a rewrite in System Verilog, under, a more restrictive open source license. And then to everybody who would like to use Corundum as a product, well, we'll have to discuss, licensing such that that's actually going to be possible in a way that you can build your product and then also support the continued development of the product at the same time. One thing that I'd like to mention is that I would love to hire some people to help build Corundum, but without an income, without revenue, that's not going to be possible. So hopefully there's going to be enough interest in the community to make this happen. So if anyone has any questions or comments, feel free to fire away. And thanks for listening.
Yeah, this is Julian here.
Hi, Julian.
Yeah, thank you very much for this talk. Um, one way I would see maybe for contributing to Corundum is through, the research project funded by the European Union and all of that. That
Mhm.
usually they are asked either by companies or by schools, and you can finance like 4 years of development or something like this from a guy. And that can be useful sometime. I don't know. It's
So that's an
I can
EU
ask.
thing. So would that only apply to work being done in the EU?
I mean, it's usually how it works. It's you express a need, and you say, we would like to work with this project, for example, and then we have to contribute. It's a requirement, and
Right,
if the project is open source, well, you know. But usually you have to demonstrate something new.
right.
You have to push something that doesn't exist yet, and that's the difficulty. So, for example, it may be the TSN, it may be something with the white rabbits or some kind of thing like this. The difficulty here I see is that Corundum supports a lot and a lot of hardware.
Right.
So doing something is good, but ensuring that this work in on every implementation and every hardware sometimes can be complicated. I see it like this.
Yeah, that definitely complicates things in terms of stuff that requires
Mm.
board level features. So something like White Rabbit, would definitely
Yeah.
require a lot of work on individual boards. Um, but the nice thing about, all the boards that Corundum supports is they really only fall into a couple of different device families. So it's like once you get something working on, say, UltraScale Plus, that's
Hmm.
like half the boards right there.
Yeah,
So,
right.
um,
And by the way, this is the most easy to get Xilinx. You just order them, and the Ultra Scale Plus boards you can get them relatively easily. While
right.
Intel, for example, I feel that it's much more complex to get them. The Intel
You mean
boards.
just to purchase them or to request them
Yeah,
or what?
to purchase them and yes, to just to order them. When you are an university, you have to go through all kind of loops to buy. You cannot just go to Mouser and order, and
Hmm.
sometimes it's complex
Okay.
for that. Hmm. And
Yeah, because
sometimes it can take 6 months just to buy the hardware. So.
right. Yeah. Yeah, I guess
Mm.
I was trying to think of my situation because we've requested a couple of different dev boards from Intel slash Altera over the years. And
Mm-hmm.
I think I seem to remember that the process of requesting the boards was pretty straightforward, but there's definitely been a pretty big delay between
Yeah.
issuing the request and actually getting the board. This iSeries board that I have here, I think took like 6 months or something between when we issued the request and when it actually showed up. But the funny thing
Yeah.
is, on one of the requests, I it might have actually been the request we put in for this board. I think I put like an Agilex F series, an Agilex I series, and then in the drop-down box for requesting boards, they also had like the Terasic DE10 Agilex. So I put that one in as well. I'm like, oh, maybe they'll send it to me, maybe they won't. So the request goes in. Like 2 days later, we get the email saying that the request, for was granted. A day later, I get an email from Teresic asking about shipping information. Then, like 3 days later, the board shows up. I'm like, this is the
Yeah, yeah, it's
fastest turnaround
impressive.
I've ever had. Just getting something. So yeah, but I guess it didn't come from Intel, right? It came from
Yeah, exactly.
Teresic. And they sent me some engineering silicon board, not the production revision. So they're probably like, oh, hey, we can get rid of this.
Yeah, and sometimes you are stuck in bugs that depends on the hardware and not even on the, you know,
Yeah, yeah,
on
that's
on pre-prod boards. Sometimes it's complex
right,
to work
yeah.
them down.
I
So,
think this
Alex,
is
I have
potentially a problem for some of the Intel parts because they seem to have a lot of engineering silicon out there, especially for the Agilex parts. I think it took a few tries to get all the kinks worked out of it.
Mm,
Um, so yeah, I think I have three different Agilex boards, and two of them are engineering silicon. And the I-series board I
mm.
have is also engineering silicon, so it's like, would be better to have a production one, but you do what you can, I
Yeah,
guess.
yeah, yeah, of
Um,
course.
and you
So,
hope that, if you have to work around a bug on the engineering silicon, that bug won't be present on the production system, you know. But
mm,
yeah,
yeah.
what can you do?
so Alex, I have a question.
Oh yeah.
Go ahead.
So can uh, can we use Corundum for optical switches? Like if I have a network with optical optical switches, so do optical switching end to end, no
Hmm.
conversion from optical to digital or electronic. If
Yeah.
can we do that with Corundum?
Yeah, I mean
To
that
do
was kind of
optical.
the original reason that we built Corundum is we were doing optical switching research at UCSD and we were running into
Mm,
problems with, traditional, commercial NICs and networking hardware. So it's like, shoot, well, what are we going to do to solve these problems? Well, if we can't modify the commercial designs, well, we'll make our own. Um, so yeah, Corundum can definitely do that. I mean, there is some dependence
excellent.
on the specific optical transceivers and data rate and stuff that you're using like 100 gig Ethernet, it doesn't switch very well. Although it depends on the data the switching rates that we're talking about. Like in your case, what kind of optical switches would you be using, or would you be interested in
We,
using?
we are interested, not any particular one, just in general,
Well,
optical switching,
like switching over what time scale?
nanoseconds.
Oh, nanoseconds. Okay.
Actually, there was a research that's published also from people in Stanford on doing time synchronization in an optical switching network with nanosecond accuracy. And I was wondering if you can achieve the same with Corundum. Are you familiar with the work in Stanford?
Possibly. Which specific work is it that you're talking about?
I forgot the name, but let me check my notes.
That's the downside with some of these big universities. They got a lot of projects going on, so it's like, oh,
Yes,
which optical switching project from from that university?
yes. It is they achieve nanosecond switching.
Right.
Let me
Yeah, I know Microsoft Research
hold
had some stuff on that
yes,
line as
Microsoft. Yes,
well.
Microsoft. Correct. It's Microsoft. Yes,
Right.
it is
Shoal?
Microsoft. Correct.
Can't remember what it was called either. Well, the problem is they had several different projects with very similar names.
Yeah, but you're right. It's a Microsoft project.
Okay.
Microsoft. I forgot the name, but they do nanoseconds time
Right, yeah, yeah. So
synchronization.
they used a fast tunable laser and AWG, I think, for the switching.
I
That
forgot.
sounds familiar, right? So
Oh, gee.
yeah.
Oh, gee.
Anyway, I mean, the idea with Corundum is that you would potentially be able to integrate, whatever, custom logic that's necessary on the physical layer in order to support that. So they were using FPGAs of some type. I can't remember off the top of my head exactly which FPGAs they were using, but potentially you could integrate, the required functionality into Corundum instead of using
Good.
just a regular Ethernet MAC and PHY and whatnot.
So we can do the same level. We can achieve the same level accuracy with Corundum, right?
Well, so not out of the box, right? Corundum would give you the interface back to the host, and then you would have to integrate, the hardware required for that type of switching. The nanosecond switching requires a lot more engineering and a lot more care than operating, switching on the second or millisecond or even microsecond level, right? At UCSD, we're doing kind of microsecond level switching, right? So we're switching like every the switch itself takes mm, maybe 5 microseconds or so to reconfigure from one configuration to the next. And we're reconfiguring it every, few hundred microseconds, something like that. And the transceivers on the FPGA are fast enough to be able to do that, without, any particular modification. So we're basically just running standard Ethernet through this thing. But if you try to get down to the nanosecond scale, then you have to really look at, how fast are you doing CDR locking, or do you have to transfer clocking information over the network somehow and do really high precision time sync? There's potentially other things that need to be done that add some more complexity. So Corundum does not like currently have support for, time sync protocols at that level. It doesn't have support, at the transceiver level for, that kind of fast locking. But the idea is that, you can add that if you need it versus, a commercial NIC where everything is set in silicon and you can't touch it.
And Virginia Tech, they have a protocol based
Mm-hmm.
on White Rabbit. It's called BestNet 3.0.
Best
Wait,
net?
BestNet, BESNet 3.0. I can send you the paper. And the Stony Brook University pursuing similar things using ARM processors and chiplets. I can also send you information about this. It sounds like this is a research that is active nowadays.
Yeah, possibly. I'm not familiar with BestNet either. I thought Best was a software switch thing, but maybe they just have a similar name.
I,
Anyway, yeah, if you send me the paper, I'll certainly take a look.
I will send you both.
Yeah,
It
sure.
sounds like you are familiar with uh,
Yeah, I'm familiar
with
with some of the stuff out of MSR.
Microsoft, exact Microsoft research. Yes. Oh, see. My other comments, there is a project that will be demonstrated in OCB Global, which you will attend. It's a project that uses Corundum. It's a programmable NIC project, and they use Corundum. I'm not sure if you know about it. The paper is called Panic. The project name is Panic.
Yeah. Yeah, they put that together a while ago, I guess. So I don't know what the current status is. Are they still working on that or
Yes, they will demonstrate it. I pushed them to demonstrate it in OCB Global, and I
okay,
think
got it.
I can forward. I can send you the lead author of this paper and project, and I introduce you, because it's good. I thought first they are using Corundum for time synchronization. They said no, they are using it as NIC.
Right. Yeah, no,
Yeah,
there's a fair number of people using Corundum as a NIC, so that's not
exactly,
surprising.
exactly. Which is good, great. So one of them, I panic. I pushed them to demonstrate it in OCB Global, and they will. So I will connect you since they are using your stuff.
Right, yeah. I mean, I think we have communicated, just not recently.
Maybe I don't remember. Maybe.
Yeah. Anyway, yeah, if you want to, make the connection, that would be cool. We can communicate. Maybe
Sure,
there's some improvements so that some cross-pollination that can be made. But
exactly.
yeah, that should be good.
Thank you. Thank you.
Yeah, and I guess I just make a quick announcement. I'm planning on attending both ISPCS and the OCP summit. So if anybody else is you're going to be attending those conferences, let me know. We can cross paths potentially. I'm going to be presenting at both of them, and I think hopefully attending the Plug Fest at ISPCS, and then having some sort of a demo at the OCP Summit. I think the details on that kind of need to be hammered out at some point, but got a couple weeks to figure that out, right? Yeah. Anyway. Well, I guess we've been communicating via email, right, Hesham?
Yeah,
Think,
absolutely.
yeah,
I was
gotcha.
talking to Ahmed. To Ahmed, he knows you very well. Ahmed from Meta.
Yeah. I was just talking with Ahmed yesterday as well about
Yeah.
some
So,
unrelated stuff, but yeah.
Ahmed, he said you and him are buddies. So I wanted to you to present the state of the art of Corundum to one of his OCB tab meeting on Wednesdays, and we'll see. The first
Right.
opening is November 6th,
Right,
but
yeah, I'll
I
check
will.
my on my calendar on that. I think that'll probably work, but I'll double check.
Yeah, and Ahmed will coordinate with you because he told me he knows you very well. So
Right,
I
right, right.
don't I don't need to interfere.
Right, and
I'm
then
I'm
if that's after the OCP summit and ISPCS, then I can present,
yes,
basically the
yes.
same stuff and summarize
You
it and
guys will
whatnot. So,
yes.
yeah.
You will meet in Germany and in Japan and in San Jose anyway. So
Yeah,
you will take
perfect.
care of it. My interest in Corundum is related to optical switching and time synchronization in optical switching. That's my own interest.
Yeah,
And
nice.
I will connect you with other people who are working on this as well.
All
thank
right.
you.
Sounds good. Well, we'll keep in touch. Does anyone else have any questions or comments?
So I have a few comments.
All right.
Uh, so the thing is, so the current code base has a very so the thing is for new contributors, right? We
Yeah.
kind of might need to have some things in place, like to make sure the code quality is like you uniform across the code base. So we might need to
Mm-hmm.
do some work there. And also like to-do list, I don't know if that makes sense. And maybe which kind of
Yeah, that
have a
could be useful, like things that we want to accomplish, and then people can pick stuff off the list. I've put up some kind of project ideas in previous meetings
yes,
and basically gotten like no response to that whatsoever. So I don't know. Maybe GitHub issues would be a better location for stuff like that. I don't know.
yeah.
Um,
Yeah, it's we we all have a lot of ideas, but so little time to do them.
Yeah, that's tricky. And then the other thing with
Mm,
Corundum too is that sometimes these ideas can require touching lots of components in the
mm.
code base, like SRIOV. I've had a number of people
Yeah.
ask about that, but it's like, okay. For
And
that to
it's a
work,
very complex subject as well. I mean, you
right,
cannot
yeah.
Yes,
improvise that if you don't know it.
Right,
For
yeah,
me,
yeah.
I
It's
would
like
like to do the 40 gigs stuff, but same thing, it's not very easy when you don't know really all these techniques. It takes a lot of time.
right, yeah. And then also, having potentially debug tools that can help figure out what the heck is going on in there. Um,
Exactly.
So, I mean, I've been trying to make stuff that I have available. Like I have this network tester thing, which I guess you can see.
Hmm. Yeah, I see.
That does 40 gig and 100 gig and 25 gig. Um, and potentially can give you a lot of visibility at the file layer.
Hmm.
And I can certainly make stuff like that available to people to use remotely, right? You load something on a board that I
Mm-hmm.
have, and I can plug it in the network tester, and you can see how badly it's broken. Um, but yeah, so far nobody's reached out to ask about anything. So it's like, oh, okay, I
Mm.
guess I'll just keep doing my own thing then. Um, but yeah, no, that's definitely something worthy of discussion to figure out what might make the most sense. And then I guess also if
also
I'm doing a rewrite,
yeah.
potentially, people could help with that on some level, but I do need to get, to get contributions with the new set up because, I need to have the copyrights for everything for the whole scheme to work. I need to get, some
Mm.
sort of a CLA in place. And if
Yeah,
we're going to
sure.
do like some sort of proprietary license, that'll have to be written by somebody. And I'll have to do some research and figure out,
How to
who
do
can
that.
help out with that sort of thing, right?
Mm.
Because
Mm.
I'm not a lawyer. So if I wrote up something like that, it probably wouldn't work properly. So
Sure.
Uh,
yeah, that's
another thing is, I think programs like I don't know if Google Summer of Code and or I think these kind of programs will help, but it usually helps to get some contributors, and it's not exactly about contributors, but it kind of makes it kind of sets a streamline method of how a new contributor can quickly join the community and can contribute. And
Yeah, possibly. It's not something the Google Summer Code is not something that I've looked into personally, but yeah, it's an interesting suggestion. I can take a look at that and see
but
what.
so low risk is there.
Hmm?
The people who build Risk 5 course, I think the low
Oh,
risk, right? I don't know if you
oh,
know
low
them.
risk. Yeah, okay.
Mm.
Yeah. So those people are there. So I think definitely Corundum qualifies. I think so. I'm not sure. I have not looked into it.
Okay.
Oh, also, I wanted to ask you about two things. So, so what do you think about an app repository? Like, where people kind of push. I know that's a complex thing. Like,
It's a possibility.
you are not using.
Well, so I mean, I guess this is something to potentially mull over a bit with if you're going to rewrite the code, you might potentially think about how best to reorganize the repository for, integrating all the pieces and whatnot. So an app repository, this would mainly be like stuff to get loaded into the application section, basically. Is that kind of what
But
you're thinking?
but
So
but also not strictly close to Corundum main core code base, but something that community just push as like whatever they develop, and maybe it's not as it doesn't meet code requirements or code quality or testing requirements, things like that.
right. Well, I mean, just trying to figure out what would go in this application repository. Like it
Because
would
because
be it
because
would be Corundum
even
designs that are intended for like specific applications, so it has
yeah,
additional
yeah,
code integrated
yeah,
into it.
exactly. Both. So like Panic, right? So for say Panic they have their own repository.
Right, yeah.
Mm.
But
Actually, at Smiles,
and
that's exactly what we did. We built something on the top of an on the app section.
Hmm.
We kept Corundum like this, and we just built some TKs and all of that. I don't know exactly because I'm not the specialist. Within the app section, and it's working. We are trying to do
yeah.
it on we are trying to test it on the hardware now after simulation.
Okay.
So that's one contribution that we could do right away before the end of the month. You know?
And this would just be kind of an example
Yeah,
application. Yeah.
Yeah,
actually, yeah,
exactly.
exactly. And something people can use to to build their own thing afterward, or I don't know.
Right, yeah. Well, so I'm also planning on taking the circuit switching code that we've used at UCSD,
Hmm.
and because that's also sitting in a Corundum application block, and then adding that to the
Okay.
repository as well. I guess there are a few things to figure out in terms of the applications because you kind of have a sort of a many to many mapping thing, I guess, to figure out, right? Because each application, you could potentially run it on multiple different boards, and each board may require some customization or
Specific
something in
stuff.
terms of placement or something else in order to make it work. So I'm not sure the best way to handle that, in
But
terms
that
of
is
the
why
overall repository structure. So
but that is why, right? It's a different repository. So you may not strictly support everything that Corundum supports, and it loosely kind of, it's like for community where whatever they have developed or something, they have a place to push it. That's all. push it or maintain.
I mean, I guess I'm trying to understand exactly what that would be. Like, we can set up another GitHub organization and everybody can just create repositories there or something, but
Mhm.
I don't know. We're gonna have to think about the semantics of what something like that might look like.
Yeah.
Yeah, it's an interesting idea though. I mean, obviously it would be nice to have. Well, so the thing is, when you take something like an application, it doesn't necessarily have to run on every single board that
Exactly.
Corundum supports. And potentially some of these applications could also be, part of the build process, right? It's useful to have something not just as an example, but it can also be used for testing to make sure that all the application section interfaces work correctly, and we can basically make it part of the CI flow and the synthesis timing closure flow that I run periodically to make sure things are not failing too badly.
Too badly.
Yeah.
Yeah, I don't know how it will work exactly, this application stuff, but I agree that it could be a good idea to to have some kind of example, because I know that when we started our work, it took quite a lot of time,
The
to
learning
be
curve to
able.
figure out what all the
Yeah,
interfaces are and
Mhm.
stuff. Yeah.
Mhm.
exactly.
I have some documentation, but it's
Yeah.
figuring out what connects to what and how stuff flows is
Mm.
not particularly trivial when there's so many moving pieces. So yeah.
Mhm.
So yeah, it could be a good idea.
Also, what happens to Switch? I know, like maybe there's, but I just
Oh,
want to
the
ask.
Switch project?
Yeah.
Well, I mean, Carlos has still been working quite hard on getting the Switch
Hmm.
operational. He did, I don't know, I guess he probably announced at some point, right, that we have 9x9 100 gig Switch working.
Yes. Yes.
Kind of an initial version. We're still doing a lot of tweaking on that. And
Yeah, notably.
the deeper you look into it, the more bugs you find, right? More or
Yeah,
less.
now that we can test most of it, yeah, you find
Not
even
not
more.
surprising, but that's how it
Yep.
works. Yeah. But yeah, I mean, we're still trying to get that figured out in terms of what that's going to look like long term, right? Is that going to be just like a totally separate project sort of thing, or is that going to be more integrated into Corundum? I was thinking it would be useful to have at least some level of integration as like an embedded switch sort of thing, which would be very useful for SRIOV type use cases. Um, but that's definitely going to require some head scratching over exactly how that might work. So I know one thing about the Switch is that it has to run at a relatively high clock frequency in order to meet the throughput requirements with so many ports, and that causes issues with the floor planning. You got to be pretty careful about where stuff is placed in order for the thing to actually close timing, and even then it's tricky. Carlos has done lots and lots and lots of Avado runs, hoping that something doesn't fail too miserably.
Yeah,
Yeah, I imagine so.
yeah, we'll have to think about it. Yeah.
Yeah. Um, yeah, I guess that'll be kind of a longer term thing. But yeah, that is actually, thanks for bringing that up, because that's another piece. If you're going to do SRIOV support, it's one thing to add the VFIDs everywhere, but that's not enough, right?
That's not enough.
The whole point
Clearly
is that
not.
you need to actually make this look like a switch with multiple NICs sitting behind it. Otherwise, what's the point, right? Because you give each VM its own NIC, well, they have to be able to talk to each other, and they have to
Yeah.
be able to talk to the network as effectively separate hosts. And yeah, that's going to require probably somebody coming up to speed with SRIOV and reading data sheets of existing NICs to see what the capabilities look like. Because that's another thing too, is I'm not exactly sure whenever you're building something complicated, there's always trade-offs that have to be made, and I'm not sure what those trade-offs should be necessarily. So a good starting point is potentially to look at existing hardware, right? You pick some NIC that actually has documentation that supports SRIOV, and you look at, okay, well, how does it work on this thing? How much configurability does it have? And what happens when you reach the edge of that configurability, right? So I think somebody recommended like the Intel 82599, I think, chips, because those actually have a datasheet available which has all the registers in it, so you can look at that and get a sense of how that how the pieces are fit together for that and what sort of trade-offs they made. So that would definitely be another thing to look at, is, you know, just whatever small amount of documentation is actually available. And
The thing is, it
what
can
we
be
can run.
the requirement may be different between the projects.
Yeah.
If you are looking on TSN stuff, it's the trade-off will be completely different than if you want just the throw-out
Well, that's
speed.
entirely possible. Yeah. So that's
So,
definitely worth trying to take that into consideration to make,
mm,
well, to either make trade-offs that are going to work for both, or to maybe even make something configurable, right? Because
yep.
that's one major difference between an FPGA versus, you know, a hardened ASIC, right? With an FPGA, you can potentially add top-level parameters and stuff to totally change, you know, the resources allocated to various things. And you know, that gets baked into the hardware just during synthesis. So you can build a design optimized for X. You can take the same code and build a design optimized for Y just by changing a few parameters. But with a hardened, you know, ASIC, well, you
Yeah,
have to make those decisions ahead of time. So
agreed.
yeah.
Mm.
But yeah, so you're also working on TSN, it sounds like, right?
Me?
Yeah.
Yeah,
No? Or well,
yes,
just
kinda.
kinda, okay.
It's for 5G,
Right.
so we need some very strict timing on this.
Right. Well, I
But
just
for
mentioned
now,
that because Carlos is working on TSN, so there's
yeah, I know.
the switch is originally being built with the idea that
Mhm.
TSN support can be added. Although
Absolutely,
I
yeah.
guess we'll see when that happens, if that happens. We'll see. We'll see.
Yeah, we'll see.
But yeah, might be useful to share some ideas on TSN. I mean, Carlos, you've done, what have you done with TSN, right? I know you implemented something on top of Corundum to implement some
Yeah.
portion of TSN.
Uh, yeah, at the university in our research group, we have an implementation running at 1G, so we adapted it to 10G to run it on Corundum on top of an Alveo E50, but using always the application part of Corundum. So we just ran some simple tests, just seeing if we can, for example, tag the traffic or detect some stuff. But yeah, we didn't like build the whole thing for TSN. We just put some pieces there, also place it, for example, some traffic shapers uh, at the output port of the Alveo. But yeah, so like simple test. And then I also like implemented some new version of these same modules, but like for these like more high bandwidth, so that they can be, for example, run maybe at 25G or maybe at 100G, but they have not been like already like tested on hardware or anything, so only simulation. So there's still some work on that, and also to integrate that on the switch or on Corundum, because I remember that one of our initial discussions about how to implement TSN on Corundum was that maybe we should like restructure Corundum instead of adding it into the application. It could make sense to adapt all the ports logic to support that.
Well, I guess that's worth thinking about if we're doing a significant architectural overhaul of what might be able to be directly integrated into that to support things like TSN, right? Because you know, we can always add top level parameters to turn stuff off if we don't need it, but you know, I'm not sure what functionality we need and where it needs to go, but we're doing a rewrite. It's a potential, it's an opportunity to think about some of
It's
that.
the moment, yeah. It's the moment to consider that from the beginning so that it can support it architecturally.
Yeah.
So yeah, in that sense, maybe I like to like contribute on that or maybe analyze the possibility of adding this functionality.
Right. Well, I mean, if you have kind of a summary of what functionality is needed and potentially where it should be implemented for the best performance, then, you know, let's let's try to figure out where that can go, because that could be a pretty useful capability.
Okay, good. Yeah, I'll try to take a look
And
into
obviously, I
that.
think one of the major focuses of Corundum is not just going to be the time synchronization stuff, right? I mean, it's like you can get lots of NICs that can do high data rate stuff, but to do the timing stuff, that's a bit more niche, a bit more specialized. So if Corundum can do that well, then that could be a good selling point.
No, yeah, sure.
Yeah.
All right. Does anyone else have any questions or comments?
What next week is switching developer meeting, right?
Well, I mean, that's the plan. Do you have stuff you want to talk about?
No, no, yeah,
I
yeah,
guess we
sure.
didn't have any switch meetings basically last month because
Yeah,
stuff
we
came
didn't.
up. But
No, yeah, sure. Have some things prepared
well,
already.
Carlos has been busy working on stuff at UCSD, right? Got a fair number of stuff accomplished, if only Vivado wrangling. But
As always.
what's new, right? Yeah. Okay. Well,
Oh.
oh, and speaking of that, we also, I guess, need to get remote access set up so you can continue poking at the stuff here. So,
Yeah,
I
maybe.
I poked Cindy about that, and then I just haven't followed up yet. So I'll talk to Cindy about that the next day or two, and then hopefully you can get back into the servers. I just realized that one of the servers I usually connect to is not working at the moment, so I'm like, what happened? Well, I guess, I need to get that figured out because that's the same server that you're going to be using. So, yeah,
One of the
not sure what the story is of that. But yeah, we'll sort that out.
Okay, thank you.
Yeah.
Okay.
All right. Well,
Okay.
if nobody has any other questions or comments, then I guess the Switch developer meeting will be next week. I don't know if the next Chrono developer meeting will be on October 2nd. Maybe it will, maybe it won't. Depends on the schedule. I think the week after that it's ISPCS, but I may go up early, so I may be in Tokyo then. In which case, I think it'll end up at like 1 a.m., which could be a problem. So, yeah. So we may need to bump that or cancel that or something. I would say normally bump it by a week, but if you bump it by a week, then that's ISPCS. You bump it by another week, then that's OCP Summit. So October is going to be very busy for me, so maybe we'll just
Yeah.
have to cancel it and then go straight to November. But I will inform everybody via the usual channels as we get closer to that. So, yeah.
Okay.
Do check out Saga buildings.
The
So
which?
Tokyo has these Saga buildings, like basically arcade game buildings. So the total. So that
I think I know what you're talking about, right? In they call Akihabara?
yeah.
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 I've been there. I
Yeah.
was there
You've been there.
2010-ish. Yeah. So,
Okay.
yeah, no, I definitely have to check that out again. Unfortunately, I think they had some crazy arcade thing that closed a couple of years ago. Maybe it was during the pandemic or something. In Akihabara, like it might have been one of the Sega buildings. I'm not sure, but it was. And I remember seeing some posts about that, and some people were very sad about it being closed. So it's like, well, okay, that's
So when
unfortunate.
I went there was Saga 3. So there was Saga 1, 2, and 3. So
Yeah, okay. Yeah. Well, I'll check it out and let you know. Maybe. We'll see. I don't know.
okay.
I think if I'm going to be doing any traveling around Japan, it'll probably be to get away from Tokyo for a while, and then because the last time I was there, I
Uh,
spent a fair amount of time in Tokyo, and then I spent a fair amount of time up in the Tohoku region in Sendai. But I
mhm.
haven't really done too much in the kind of bottom part. So um, yeah, we'll see. I still got to figure that out. So should be good. Yeah, it's like usually when I go to a conference, I'll do like the conference first, and then I'll go travel for a few days or something. But in this case, it's ISPCS, and then the next week is OCP Summit. So that's going to be a pain on coming back, and that also means I can't stay. So I'm gonna have to go probably the week beforehand or something if I want to do any traveling. So yeah, I'll figure that out. Anyway, um, yeah, I guess if we have no more questions or comments, then we'll go ahead and wrap this up, and hopefully Carlos will see the people interested in the Switch next week. And then we'll see
Okay.
everybody else in a month or two, I suppose. And if people want to discuss, the Corundum rewrite stuff, licensing and whatnot offline, feel free to contact me directly. So, all right.
Thank you, Alex.
Well, we'll go ahead and
Okay.
wrap it
Thank
up.
you very
So
much.
thanks everyone for
Yeah, thanks.
attending, and
Thanks.
we'll see you later.
Yep. Thanks.
Thank you.
Bye.
See you. Bye.